Alright, so once you're done with pre-processing, we're going to go through the steps of actual processing it. So the first thing you're going to want to do is you're going to pull up, you are going to want to navigate to wherever you saved your files. So in this case, it's going to be our WBP2. I'm actually going to use the files in the original one. So we're going to go to your WBPP file. Go to master and go here. You're going to want for the ones that say your filter underscore mono underscore auto crop. So you should have, in this case, we're going to have blue, green, luminance, and red. And we're just going to command click or control click on Windows, all of them, and then just drag them over into this empty space here, and they'll just load all up. So they're going to come with these crop masks. You can just X them out. You're never going to use them. And now you notice we have a bunch of mostly black images. Now this is because these images are what we call linear, which means that this is an accurate representation of what the sky looks like. So that is a star you could see. It's a very bright one, and you see those stars, but you wouldn't see the actual nebula itself. So in order to do that, we have to do some fancy things called stretching it. But that is very intensive, and doing a permanent one takes a while. So we have this handy little tool called auto stretch. So you're going to want to go here, find screen transfer function, open it up, and then press this little radiation icon. You can also press it up here and it'll do a similar thing. But I generally like having the screen transfer function open because it becomes useful later. So we'll see, we have 4 images here. We can hover over here to find that this is red, and we're going to rename it to red. And this is luminance, and so we're going to rename it that. We're just going to do the same thing down the line for green and for blue. Okay, you're going to want to minimize this luminance, so this little, or iconize, it'll become this little tab. You can drag it over here to this side of this yellow line. And this yellow line is really just a workplace separator. The next thing that you're going to want to do, so you can just put these over here. This is the guide. Feel free to have this open on the Chrome tab. I just have this open in the in-browser window so that you can all see where we are going. So then I'm going to go back to a file explorer. You're going to go to this Pixinsight file. What you should see is something called process.xpsm somewhere in this folder. It also might be called French process icons. You should use whichever one. Here, we can move that away. You should use whichever one is newest. So you're going to open this up, and it should. So these are the process. Oh, please stop. So these here are the processes that you're going to do down here in this image. So the first thing we're going to do is we have our RGB images. So we're going to do combine RGB. So we take this. There's generally going to be 3 or 4 buttons in this corner. There's this, which is new. This triangle, which is new instance. The square, which is apply, and the circle, which is apply global. For each process, you're going to do something different. Generally, if you're selected on an image and you press the square, it's going to do it to that. If you press the circle, it'll apply it to everything it can apply to. Or you can drag this little triangle on top of whichever thing you want to do it on. And so if I drag it on top of the blue, it'll apply to the blue. So those are the 3 filled in shapes, and that's what we're going to need to do. In this case, we're just going to press the apply global circle because we already have a red, green, and blue. It's going to spit out an image. We're going to name this RGB because that's what it is. And then we can close our red, our green, and our blue. Next thing we're going to do is we're going to come back to our screen transfer function because if it, this is not exactly useful to look at. So we can close this. So we want, again, to stretch it. So we can stretch it like this. This doesn't look quite right. It is clearly overly orange, and that is because we have our channels linked, so it all stretches them the same amount. If we unlink them and restretch, you can see that this is a much more accurate representation of what the image should probably look like. It's not a perfect, it is not an actual representation of the pixel colors in the image, but it gets us good enough that we can see what's happening. So we're going to go here, and our next step is to do gradient correction. Well, gradient correction, it's like automatic convergence. Drag the little triangle over to here, and let it apply. So over here, you're going to have, you can see what it's doing right now. So it's processing gradient correction, and then it is giving you the log of what it's doing. So what the gradient correction does, it takes, and it will be very visible. You see how this corner is like orange, and this is less orange, and now it's all kind of uniform across the sky. So that's what that gradient correction is doing. So it's correcting the background gradient. Next thing we want to do is we want to do background neutralization. We want our reference image to be RGB, and this region of interest. So there's this tool called previews, which is essentially you can take a smaller section of the sky. So what we're going to do is come up to here, new preview, or Alt-N, and just take a preview that doesn't include any bright stars, but is generally the background color of the sky. And so you can see that that's pretty good representation of the background. And I'm going to press from preview here, select the preview we just made, press OK. These previews are useful because you can actually say you want to focus in on a specific area. You can make a preview, test out what the process does on that area, and then apply it to the whole image if you like what it does. In our case, we don't really need to do that because of another feature that we'll learn more later. But again, we're going to take this triangle, drag it over, and now you'll notice it has neutralized the background. You'll notice that it looks odd because it has essentially taken the background color and just washed it out and taken it away. So it left the stars and the nebula, but it really killed a lot of the background color that was previously in the image. We're going to stretch it again. And now, while this looks similar, you can see that now this was originally the image we were working with and had this, film over it, essentially, of the background color. So we just told it, take that background color, get rid of it. So now this background is a lot less colorful than it used to be. But we can just still see it. Next step is you're going to want this RC Astro Blur Exterminator. If it's not working, you should make sure that it says permanently licensed down here. That should say that, but you're gonna if it doesn't say that, you're gonna need to buy a license or check with the observatory operator as to who has a license. So you're gonna want it to look like this. Take again the triangle and just drag it over. So what this is this is an AI model that has been trained on reducing the blur in images. These are all the exterminators. So we have blur, noise, and stars. They're each trained to do one thing. So this blur exterminator is trained to get rid of blur and to make images sharper. And the star exterminator is trained to process stars, and the noise exterminator is to get rid of background noise, like all of this, because clearly this is not the actual color of the background with these greens and pinks and reds and blues. But it stays for now for reasons. So you'll notice here we select correct only, and really what this is doing is taking these little bit potato shaped stars. We know that stars should be round, not potato shaped, so it makes them round. Does this over the whole image, and as you can see, kind of hard to see, but it just corrects it. It makes it look a bit nicer for the next steps. So the next step, and it's notably not in the process icons, but you'll find it in Process Explorer, scripts, astrometry, and image solver. So this is the image solver's script right here. You're going to note that this is the script that will pop up if your image solving fails for your WBPP processing. It'll look just like this, and you want a couple things to do. So first, you're going to search. You're going to go, in this case, it's I443. Search the identifier of whatever image you're doing. Press OK. You're going to, you can ignore a lot of this. The thing that you should pay very close attention to, this pixel size should be 12 microns, and this focal distance should be 4,211 if you are using the Ritchie Crane telescope at the observatory. If it is not a number like this, and it is a number around 1,500, which it might be, because these images were, not all of them were given the right metadata, you're just going to want to make sure, set your resolution to 0.588 inches per pixel, and it'll figure it out from there. Next thing is model parameters. Make sure to check local XPSD and Gaia DR3. Don't try anything else. This will be downloaded. You're going to have to set this up in the, it won't work right now. No. You might have to set this up, but you should not have to, and you should talk to someone if this doesn't work, because it should really work. You can ignore advanced parameters, distortion correction, and just press OK. And what this is doing is it is essentially looking at all of the stars in your image. So it's finding them, and then it's matching them up with some very precise images of the sky and saying, okay, well, this is somewhere on the sky, so where is this corner, where is this corner, where's the middle? So like, we're going to map this onto a map of the sky. You'll see that it'll finish very soon. And now it has mapped it onto the sky. So we can use our next process, which is called spectrophotometric color calibration. And what this does is it essentially looks at the sky, looks at the background color that it is right now, compares them, and then changes it to fix. So you're going to want to leave most of this like this. Make sure this is Gaia DR3 SP. And then from preview, original preview, take a little triangle, drag it over, and it will solve the actual colors in the background. Okay, so once it's done, you'll see it creates these graphs. These graphs are essentially just it creates a model of what it should be, so what the colors should be. So this is a ratio between the red and the green color in the catalog and what it is in the image, and it plots them on a graph and then draws a line to match it. And it does this for red divided by green and blue divided by green. And you can see that there are these two models, these two linear models, and it applies them to the image, and you get an image that is more accurate to colors that it should be. So you can close that, close that. So now we have our RGB color calibration. We're then going to come back to Blur Exterminator, and this time we don't have correct only, because we actually want some of these images, we want these stars to be sharper and smaller. So we're going to leave it like this, take the triangle, come over and process it. Okay, so once we're done, and this is something that you will very definitely notice the difference. So especially with stars, you can see how they're not really points, they're kind of fuzzy, and now they're much smaller. Centers are typically brighter. Like the very center is bright, but maybe less bright actually. And you can just see that the detail has really, like you can see even these smaller stars, the centers get brighter in a lot of cases, and they also just get smaller so that they look more like point sources that they are, instead of like these big things. So This is a noticeable difference. So we're done here. I'm going to take the star exterminator. I want to select large overlap. Take this triangle, bring it over. So what this is going to do is it's going to go through, it's going to take all the stars, and it's going to take them out. And produce an image, a version of this, where it has all of the stars, and one where it has none of the stars. Okay, so you can see, now we have just our nebula over here, and just our stars over here. You should, on Windows it's Control-Shift-S, on Mac it's Command-Shift-S, but use Command-Shift-S. Make sure you're in the right folder. And to save this, should be XISF is your file format, and you can save it as RGB_stars. That's what I usually do. I'm not going to save it in this case because again I've created this before. Save it as RGB stars. So that, and then you should also save this here. So actually, I'm just gonna. Not there. Let's just call this RGB stars too. We'll save it. So you should have this. It should look like this. 32-bit. None of that. None of that. As many of these as are there. It'll auto check preview rectangles if there are previews. Just press OK. It'll save it. Do the same thing over here. 2. Save. Okay. I'll save. Okay. So this we can then iconize and drag over here with our luminance. And we have one more step here, which is to take our, close that, take our noise exterminator. The setup should be like this, and then we're going to apply it. And now what this is going to do is it's essentially going to smooth out the background, so all those little bumps of color and of brightness in the background should smooth into a much cleaner gradient. Okay, so you notice pretty immediately there's all this color. Now it's much flatter. There's still a little bit of grain left over. If you do it, this is because we have 90 and 80 and it's not perfect. If you do 100%, it can actually look rather odd, but that's that way. You also notice that there's this weird spot over here, especially before I denoise it, where it's all one color, and that is actually the star exterminator taking the star out. So it looks weird now. When I go over here, it looks even weirder because it creates this like weird spot in the nebulosity. But actually, you'll eventually add the stars back in to this, and when you do, it'll cover up that weird spot, and so it will stop that. Okay, so this is your linear image. As a reminder, this is what the image truly looks like. You can see down here once I hover over, or once I do this, you can see that the RGB values are all very, very small, like 0.002 or 0002. Sometimes when it gets really bright in the red, 0.003. But this is what the image looks like. We are just pretending it looks like something else. If we, it'll look weird if you stretch and unstretch it. Don't care too much about it. So we have our RGB image. It will not look like this. This is just a stretching thing again. And so that's ready for processing. So we're going to close it and move over here. And then we're going to take our luminance over here. The steps that we do with this luminance are going to be the same steps as if you were processing narrowband images. So that's with H-alpha, sulfur 2, and oxygen 3. You're going to want to follow the same steps that you do over here. And then the finalizing steps will be slightly different. And I would refer to the guide by Philippe Bernhard, which you should be able to find online if you search up Philippe Bernhard. So we're going to come here, we're going to do our gradient correction. We're going to click automatic convergence. I'm going to apply it. And this is going to go pretty fast because it is many of the same steps that we did for the RGB, just faster. Now we're going to take this blur exterminator, make sure it's not correct only, come over here, make it happy. Cool. So again, you can see like this, the whiter side and the blacker side, and then it's even color gradient. Now all the stars are smaller. And we're going to take the star exterminator. We're going to unclick the generate star image because we don't want the star image. If you're using, if you're not doing a luminance image and you're doing narrow band processing, you should generate this star image because you'll need it. For our case, we won't, so we're not going to generate it. So we're going to come over here, apply it. And then once that's done, we're going to again come back to our noise exterminator, come over here and apply it. Cool. So now this image is done. So we're going to go again, save new image file. We're going to want to make sure we're saving in IC43. And we're just going to call this loom 2 dot xisf and save it. Okay. So now we have our RGB stars, our RGB, and our luminance files all saved, and we're ready for stretching.